Let's go, shall we? This is meant to be just a little bit of, this is very little practice and a little bit of review notes. Don't try to use this as, oh, you forgot this or you forgot that. So there are only a few things. Reviewing the big ideas. Are you ready?
Yes.
Okay. So set 112 and 113 was trig sub. If you know your identities, then the trig sub, and you understand the concept, the trig sub isn't a lot of studying, it's more conceptual. But in essence, you're going to either use sine, tangent, or secant for trig sub. And then after you trig sub effectively, then it draws on your trig integration skills, which is set, 100, 76, and 83. So let's make sure you remember a few basic antiderivatives. Would you add in here, be able to do, yes, integrate sine cube, or secant cube, excuse me. Yep. Okay? Anyway, secant, what's the antiderivative? Natural log of secant plus tangent. And a lot of is all I heard. What about cosecant?
Natural log.
Cosecant minus cotangent. All right? Tangent, which if you got stuck, you'd use sine over cosine. But what is it quickly? Okay? And cotangent. Sine. Again, you could use sub it if you didn't remember. Power reduction identities. What's cosine squared equal to? 1/2 plus 1/2 cosine of 2x. And sine squared is 1/2 minus. All the others are conceptual. Sine cubed is conceptual. You strip off an odd for your du and so on. Tangent squares, conceptual. All right. Exponential indeterminate forms. That is the idea of using e and natural log, then later L'Hopital. Actually, then make a quotient, then use L'Hopital. And I'm talking good L'Hopital work, not sloppy at L'Hopital work. What are these 7 indeterminate forms? Give me the 3 exponentials first. Infinity to the 0. What else? 1 to the infinity and 0 to the 0. Okay? What are the 2 original L'Hopital? 0 over 0 and infinity over infinity, and that could be plus or minus actually. And then, what is the product indeterminate form? Infinity times approaching 0, and what's the difference in indeterminate form? Infinity minus infinity. Anything else is not indeterminate. So you should think bigs and smalls to evaluate it. All right, let's go to 110 and 106. They're both polar. First, vocabulary. When I say graph and rectangular, what does that mean? X and Y. And if I say graphing and polar, it means R and theta. Okay? There are 4 conversion facts, all of them governed by this picture. X, Y, theta, and R. Give me 4 conversion facts. X is R cosine theta, I heard. What else? Maybe I'm... Y is R sine theta. I heard another one about squares. X squared plus Y squared is R squared, and...
Cosine squared theta plus sine squared theta?
No. Good try that. Tangent of theta equals y over x. Or I guess you could look at that in an inverse tangent way also. Okay? You should recognize these equations and know their graphs just by looking at the equation. R equals A is a circle, symmetric at the origin. R equals A theta, spiral. make sure you graph at the axes. Theta equal A. There's a line through the origin. R equals A cosine theta. Circle symmetric where? At the x-axis. Radius of A or diameter of A? Diameter of A. R equals A sine theta. Circle symmetric at the y-axis. R equals A cosine B theta. B theta, like cosine of 2 theta, cosine of 3 theta, cosine of flower. So rose, symmetric at the x-axis. Where's the first petal on? Actually, it's later. Never mind. What about R equals A sine B theta? Rose symmetric at the y-axis. And would you please put plus or minus y-axis? It doesn't have to be at 90. Sometimes it's at 270. Or 3 pi over 2. On roses, if B is even, for example, cosine of 2 theta, then how many petals? The number of petals is double, yeah. So if, generally if it's B, and B is even, then there will be 2B petals, yeah? If B is odd, then the number of petals is just B. For cosine, where's the first petal? A petal happens, the tip of a petal happens when R is at its greatest. You're going out as far as you can. When is cosine at its greatest? 0. Sine's first petal is when sine is at its greatest, so that means when B theta, or the argument, equals 90 degrees or pi over 2, yeah? Okay? So for example, sine of 5 theta, where would the first petal be in degrees? 18 degrees. Okay, when 5 theta equals 90 degrees, that means theta would be 18 degrees. What's the spacing on sine of 5 theta between the petals? The petals should be evenly spaced. It's not how your graphs were when I graded them. So that would be 72. So you need to know where the original petal is and what the spacing is to find where petals are placed. It's 360 divided by the number of petals. And obviously that's different based on even or odd. You follow? Okay, going back to 109. There are 2 or 3 people in each class who are remembering the arc length formula wrong, so remember it correctly. It is the integral of the square root of 1 plus, not minus, it's plus, and f prime squared, the derivative, not f. I'm seeing people use minus, I'm seeing people use f, not f prime. Okay, vectors. The extra credit for the vector thing is applicable. If you're wanting to trade your dignity for a few points, it's okay. The only thing, there are many concepts there. Remember, this is component form. It's the same as this. And remember, this notation is magnitude or length of the vector or hypotenuse, not absolute value. You follow? Okay, parametric. Parametric, you need to be able to do trig or algebraic. Trig, you eliminate the parameter by using an identity. Algebraic, you use substitution. Please, I beg you, don't forget the domain. Also a common mistake on the homework I was seeing. When you eliminate the parameter, you must include domain restrictions. On the graph, make sure you show initial position and direction. The graph is not just like an XY graph. There's a little more to it than that. You're showing movement. Follow? Sequences, you use the limit. That says use Use limits to show converge or diverge. You may use end behavior. You do not have to use L'Hopital in that. End behavior, okay. Not L'Hopital unless you want to, but I don't require it. Okay? Be able to draw a slope field or read a slope field. If you feel iffy on, and most people are doing fine there. If you felt iffy, I'd go back to the homework on that or the worksheet on it. Delta epsilon proof of a limit, be able to do linear or a curve. And I haven't decided if I'll just say, hey, find the delta. If that's good enough, I actually want to see a rigorous proof. I haven't decided for linear, what's delta? Linear delta is epsilon over the absolute value of the slope. Make sure you use absolute value, you're going to confuse yourself. Without the absolute value and the negative, things get very dicey. Okay, definition of E. What is E by calculus definition? The limit as U goes to infinity of 1 plus 1 over U to the U. All right, and be able to adapt that definition to based on different numbers. Trig integration skills, that's there. Differentials. Show this delta y is approximately dy f prime dx, or whatever the variables might be. But that has got to be on your paper. I graded, I looked at one of those on the homework, I can't remember which one, but if it says estimate the square root of whatever using differentials, and nowhere in the box do I see a differential, you're probably not going to get credit, very much credit. If it says use differentials, I should, maybe see a differential in the problem. All right. Number 98 is fundamental theorem part 2. That involves not just the derivative and the antiderivative of inverses, but also possibly a chain rule kind of component. What if you had the integral from 5 to cosine of x of e to the negative t squared dt, and you took the derivative on it? What is it? E to the negative cosine squared of x. That's negative sine of x. Okay, cool. Log. What is log of x defined as in calculus? Integral from 1 to x of 1 over t dt. The area log is defined as the area under 1 over t. Now that could be used to estimate log if we use trapezoids, so we use that in conjunction with trapezoids or Simpson's rule. Oh man, I should have put that on there. Dang it, I should have put a Simpson's rule. I think it was on one before, but so at least it's been on one. And error bound. I will give you the error bound formula. You do not have to memorize it. Okay? Area of known cross sections. There's some stuff to memorize, but the big picture is that the volume of some kind of figure can be done, or at least estimated, by adding many cross-sectional volumes. That is by far the big idea. So think, besides the ones you've done, I also would love to see that you understand the concept. So if I said, hey, here's a tree, and I gave you cross sections here and here and here, could you estimate the volume of that? I would hope so, saying, well, I could just find some cylinders and add them, and that would be an estimate. And then it would depend on right or left, trapezoids, and all that good stuff, yeah? Here's a blood vessel, and it's constricted at some places. And I could say, here's some cross sections. Estimate the volume of the blood vessel. Here's a river. And each cross section is a semicircle. And based on that, how much volume? The idea of summing cross sections to estimate volume is a big idea that you should understand conceptually. You with me? Then besides that, you have the semicircle idea. Semicircle is typically pi over 8 times the diameter squared dx or y, right? Equilateral triangle is typically root 3 over 4, which comes from the 1/2 AB sine C idea with the sine of 60 times the side squared dx or y. Squares are easy, rectangles are pretty easy. Isosceles are pretty close, but I won't go there. Are you good? Okay, fluid force or fluid force. You had one of these the other day on review 1, I believe. The bounds, what do they pertain to? Actually, first of all, would you write yourself a note, please? Draw. Show the origin. I've got to, in order to give you partial credit, I have to know what does your y mean. If you don't have a picture, I can give you nothing. All right, you've got to communicate, this is where my origin is. All right, now, the fluid force, what are the bounds? Container or liquid? Low. Liquid, yeah. Liquid low, liquid high. It's rho dA. Rho is the weight density. That matters in force. D is D depth or distance? Depth. And that depth, that's the distance. It's a vertical distance. Every one of these is dy. If you're using x on fluid force or work, you have no idea what you're doing. I'm going to waste my time with that. Okay? It's always y. Always. Everything. Okay? Now, that said, the depth is relative to the surface of the container or the top of the surface of the fluid or the top of the container? Fluid. Okay, so it's surface minus y for the depth. Okay. The depth is relative to where you're at in the surface. The area. The area could be a constant, it could be x, it could be 2x for the width times dy for the height. Give me an example here. What if I had a container like this? When I say the area of the cross sections, is that constant x or 2xy? That's xy, okay? What about this? Is that constant x or 2xy?
That's constant.
Constant. Okay, what about this? Oops, you would draw a circle, should always be centered at the origin. What is that width? 2x, okay? All right. Work. Work is, do the limits change for work, or is it still liquid low to liquid high? Still where the liquid is, liquid low to liquid high. Rho is rho. D here stands for distance. When you pump a fluid out over the top of the container, well, it's relative to the top of the container. So top of the container minus y for distance. And it's not so much area. You need to pump volume out. And so that's usually rho times area, or it's not rho, area, what is it? So it's how wide it is, cx or dx, dy, and then how long, yeah? Area times the length, I guess you could say. All right, cool. Newton's method, what is it used for? Used to find, or used to estimate, rather? Estimate zeros. So you first make it a zero problem. That's the first order of business. Identify a function equal to 0, then go from there. What is the general formula? The n minus 1 integration or permutation of Newton's method is, or the nth, sorry, I don't know why I was saying n minus 1. The nth iteration of Newton's method is? Let's say n minus 1, is it minus or plus? Minus f or f prime on top? Okay. Make sure you show the function and the derivative somewhere on your work. In your work. Volume by shells is conceptual, and you guys seem to be good with it. Distance, is it integrating v or absolute value of v? Absolute value of v. Now, if that's without a calculator, what do you got to do? Now, what's the key to integrating absolute value? Use piecewise. Figure out where it's negative or positive. All right, and then slant asymptotes. How do you find slant asymptotes? You divide. That could be either synthetic or long division. I did put a problem on that. I haven't had one of those on the reviews yet. There's one. I think it's the first one. Okay, that is that. I will put the answers to this. They're not many problems there. It's pretty late. I'll put the answers to this online on my website under today in the calendar. No later than tomorrow afternoon, but preferably tonight. Questions on review 1 or 2? 7 on 2. Review 2, number 7. Okay. Some of the numbers are all over the place or repeated. Not bad. You guys are good.
Oh, number 4 on the first one.
Review 1, number 4.
Yeah, can we just check? I don't have like a magnitude for the error.
Magnitude of the error bound, yes, that is by far the hard part of that problem. Yes. We'll talk about that. 5C on 2. Okay.
3A, the first one, 3A is your typo.
Review 1, 3A, and C.
Hyperbolic trig on the first one.
Hyperbolic trig. It's been a while. Okay? Oh, I should have put that, should have been on here, don't it? Okay? Here we go. Review 2, number 7. The only question is there more than one number 7? Cool. All right. So, review 2, number 7. They tell you it's got a parametric equation system kind of thing. You've got parametric. They give you dx dt. At time equal 3. Position is 2, 7. What is x at time 6? Okay, cool. So part of this is knowing what to use and what not to use. So there's some kind of, I don't know what's going on, kind of movement, and I know how x is changing with time. I also know an initial position. Now, the only thing that really matters is what the initial x is, not the y so much, because they only ask me what is the x at 6. So think of this as, like you've been doing forever, initial or some kind of known point plus the change, the displacement change. In this case, though, we don't know x initial. We know x at time 3. So I'm not actually going to say the position at 6 would be the position at time 3 plus the change in horizontal position over the time frame. Well, the time frame, what are the limits then? If I know 3 to 6. And dx dt, so this is the rate at which x is changing. I would multiply that by little increments of time to get total change in x. And so from there, it's fundamental theorem. It is non-integrable, so use your calculator.
Why is it square rooted?
I have no idea. I don't know. It's a good question, good critical thinking here, Brandon. All right, are we good? There's no reason for it to be forward. Review 1, number 4, the error bound. This we might not be at mastery yet on, but this is great practice for second semester and good error bound practice. It won't be this hard on the hands. Review 1, number 4. So, you are estimating this, if I recall, and you estimated that in A and B you're doing the error bound. You're showing the error is less than 11. Okay, now if you're thinking, gosh, that's a lot of error for such a small region, 0 to 1, remember exponential is super fast growing, so it's easy to get a lot of error on something that goes that fast. So, start here. We know that error is less than or equal to b minus a cubed over 12n squared times n. Yay?
Yay.
All right, the easy part is the 1 minus 0, and the n, we use 3 trapezoids in part A. Now the part that you're asking about m. Why is it what it is? Now, m is thought of in 2 levels, max or an upper bound on f double, on the interval. And that's the absolute value of f double on 0 to 1. So, if f is e to the 3x squared, and f prime is e to the 3x squared times 6x, and f double is e to the 3x squared times 6 plus 6x times e to the 3x squared times 6x. You done? Now, I have a I'm trying to say, what's the max of this on 0 to 1? Do you want to clean it up or just look at it the way it is? Okay, you could clean it up. You could take out front a 6 and an e to the 3x squared, leaving you with 1 plus 6x squared, yeah? The key is to say, well, what happens on 0 to 1? Is it constantly growing, constantly shrinking, or maybe there's a max inside? As x passes from 0 to 1, would this get bigger or smaller? It's bigger and bigger, all right? So the max is at x equal 1. The max is 6e cubed times 7, or 42e cubed, yeah? All right. Now, a big idea of calculus is often that, if you don't know e to the 3x squared from 0 to 1, you probably don't know 42e cubed either. So it's pretty common, this will be more second semester, it's pretty common that you make this a cleaner version. Now, you know that e is less than 3, okay? And therefore, e cubed is less than 27. And 42e cubed must be less than 42 times 27. Now, an m of 42 times 27 might not be the least upper bound, but it is an upper bound. And it's a lot cleaner to work with. In my note then, when I said use the fact that e is less than 3, then let's say that the error is less than or equal to 1 over 12 times 3 times 3. And for m, I'm going to use a nice clean m of 12 times 27. And the reason being, it'll be easier to show that's less than 11 than that big mess of e cubed times 42. We're trying to show I'm trying to demonstrate this is less than 11. Now, hold off on that. Let's clean this up. if I clean this up, I get the 12s and the no, you're fine. This is a 42. Sorry, my bad. So you said, what did you say here? 2. Oh, come on, think, Corey. I just got stuck. So 2 and 6 goes into that twice and 7 times. We into that 3 times. So area is less than or equal to 21 halves. We and that's 10 and a half. And isn't that less than 11? So if the area is less than 21 halves, it must be less than 1. Now you couldn't have really made that connection without going to the clean version. That's the idea. You with me? All right. Review 2 5Cs. Review 2 5C equations. Okay. How many 5s are there? So you mean the lower 5, I'm sure, yes? Okay, this one was a humdinger. This was hard. So you're okay with A and B, the eliminating the parameter and the domain restrictions, and just doing C, yeah? Okay, so we have that x is 3 root 1 plus sine t, and y is 2 cosine squared t, and y is negative 2. Okay, so we're trying to show that dy dx could be thought of 2 ways and that they have to be equal. So let's go here. This would say that dy dx is negative 4 x squared over 9 minus 1 to the first times the 2x over 9, yay? And therefore negative 8x over 9 times x squared over 9 minus 1. I'm not sure if that's a clean enough form, but I'll leave it at that. You with me so far? All right, now we also know that we could find dy dx by taking the derivative with respect to t. dy dt is 4 cosine of t times negative sine of t over 3, 2 root 1 plus sine t's cosine of t. All right, so the first part is to get the 2 derivatives. So far, so good? Yes? No?
Yeah.
Okay, now the hard part is to prove they're equal. How can I prove those 2 are equal? Okay, so x's, you could say x's are, x is the same as root 3, 1 plus sine t, eh? Question is, shall I sub in for this and take the x's to t's? Or should I sub in for this and take the t's to x's? What do you want to do? I don't care, either way. Okay, so let's go this way then. I'm going to substitute in place of each of these. First, before I substitute, I'm going to clean up. This is negative 4 cosine t sine t. And if I multiply this reciprocal up, what's that, yay? Cosines drop away. And now I'm going to take the negative 8/3 and substitute in for this trig stuff. What's sine of t equal to? Sine of t would be x over 3 squared, subtract 1, right? So x over 3 squared, so x squared over 9, subtract 1. And the root 1 plus sine t, what's that equal to? X over 3. Well, isn't that then, if I combine the negative 8/3 with the x over 3, isn't that negative 8x over 9? X squared over 9 minus 1, which is what? Looks like dy dx is. Yeah, they have to. It's true. All right. Review 1, number 3, A and C. Anybody need that?
Just C.
Just C. Review 1, 3C. How many row roots does the polynomial have? Is that part? Oh, there's 2 C's.
Yeah.
You want the first C or the second C? Okay. That's fun. You can never have too many C's in it, right? X cubed minus 2x squared plus 3x plus 3. This has to have a 0. I know a cube has to have a 0. And this is not calculator active. Okay, so first I have to kind of get a feel for where it's at. I know that a cube shape, no matter what it does, has to go forever up and forever down. I looked at this part first, and I know that it's below, and eventually it has to end above, so I started looking on the positive side. So at 1, whether you use synthetic or not is up to you. You could just do kind of plug and chug. 1 is 1 minus 2 plus 3 minus 3. 1 is negative 1. So it's still below at 1. But f at 2, I think it's probably coming up. 8 minus 8 plus 6 minus 3 is 3. And so in terms of an initial, I would use either 1 or 2. X equal 1 or x equal 2 is a good x initial. 1's easier to work with, so I'm going to use 1. So I know the function is x cubed minus 2x squared plus 3x minus 3. The derivative, for the record, is 3x squared minus 4x plus 3. My initial is 1. And here I go with my first iteration. X of 1 is x initial minus f of x initial over f prime of x initial. That's 1 minus f at 1 over f prime at 1. I earlier found f of 1. It's negative 1. And f prime at 1 is 3 minus 4 plus 3. So 2. So I get 1 plus 1 half. I'm getting 3 halves. Okay?
How would you put it into your calculator to get the 4 more 3?
So the process goes this way. It's the quickest way, is to first put f into f1 and f prime into f2. Excuse me, which I'll do in a sec. And there's some storing and storing over kind of process. So, excuse me. So this was x cubed minus 3, I don't remember. So minus 2x squared plus 3x minus 3. 2x squared minus 3x minus 3. I think that's right. Plus 3x. Okay. All right. F2 in the 3x squared minus 4x plus 3. Sorry, just a second. 3x squared minus 4x plus 3. Okay. Are we cool? The code, or the, not code really so much as, so you store your first, I think we have 1 is our original x, yeah? So I'm going to say store 1 to x. Now, I'm going to have the calculator call up the previous x. Then subtract away the function at that x divided by the derivative at that x, but don't hit enter because after you calculate that, you want to have the calculator store it over the old x. And then you hit enter. That's the first iteration. The second iteration then, that's x2, x3, x4, x5. I was not about to write all that, so I said that is approximately equal to 1.3926. Okay? All right. Can't remember what that was. That was review 1, number 3, and C. Hyperbolic trig. Does anybody need hyperbolic trig still? Yeah. Okay. So only the smallest stuff. The derivative of each is itself. You can, if you know these, you pretty much are home free. But the derivative of sinh is cosh. And the derivative of cosh is sinh, no negative. And the identity, pretty sure it's subtraction. I'm 80% sure that's. Okay, let me know if you have other questions. That's the big idea. Start there. I think that'll get you started. Then relative error. Relative and percent are that compared to what is the radius. Is that a lot? You can actually have this climb from those once you do that, then it's relative error. So, dV is the error they gave you. The volume could be off by. What was that? The volume could be off by as much as 1. This is 4 pi r squared. Unfortunately, you don't know our initial either, but if the volume is 100, that implies r is some ugly decimal. So that'll be at that, and then dr is that which you're solving for. So dr would be something like 1 over. Does that help?
Sick, but they're all like standing there. Because he got his hand cut off, remember? And so he's like getting yeah, that's the one. That sounds right.
Wait.
Empire Strikes Back. That ending soundtrack.
How are you?
How big? I think it's no, I'm sure it's very small. Is it? Oh, good. I know Sean's playing this one. Yeah, I think it's better. What'd you say?
I did take Calc 2. I was surprised to take Calc 3.
You
I
said
think
start off
I took Calc 2 and then they told me Calc 3 was better.
Well, it's funny, despite being many states away from each other, we were doing a lot of our homework together,
Oh, really?
helping each other out with it. Sequences and series!
Yeah.
Comparisons, it was easier the second time around.
Yeah, I should say so.
That time here wasn't fun.
I think calculator is better myself. Calculator is more like calculator.
Does it, like, make more sense?
Yeah.
Because first getting into calc and doing all the like physics applications, velocity and acceleration, that type of stuff, I love that because it made sense and it clicked.
Yeah.
But like sequences and series and divergence tests and all that stuff, yeah, exactly.
Yeah, Calc 3 is more applicable, and it's more related to physics. So, yeah, I like that one better. You went to mine, right?
Yep.
Yes, ma'am. Sorry.
I just have a question.
Sure.
So, on the, what's it called, campus portal? Well, it says that, 103 and the 104, these ones are the same. But I
Our
took,
exams were like one day off.
the other ones I did, because I had
103
to.
and 104 extra practice.
Yes. And then the test I took when I was gone for state,
That's not in there.
no. I don't think it's in for 20. Sorry, Miss 20.
No, it's fine. Absent to a plan is fine. No, I often make mistakes. Okay, I'll look into it after school.
Okay, thank you.
You're welcome. Hi.
Josh said that your stuff has been improved. So, maybe you guys will
Eating microwave pizza driving up
during
when you
finals,
get
I'll
here.
send them in the mass saying, hey, be sure to let me know if the kids that are advanced are getting C's that you think should be moved down a semester. Let me know. But in there is a cool form to say, like, with the understanding that it's not because they're missing assignments, but because there's an understanding criteria.
Dude, we literally
I mean, I don't want to put words in your mouth.
Yeah.
We're that close.
Explain why you suggest that to the parent. Is that what you're saying?
Yeah.
Yeah, right. So,
No.
Sure, so I should send a message out to the math department
to send Greg and
I mean, I feel like that's a good example of.
and counseling.
counselors, yeah.
Know about. Are we talking about the ones that actually do say, yes, I'll be moved, or we're moving, or the ones that just will receive judgment?
No,
They probably don't need to be told about the ones that suggested to the parents.
And
but
have denied.
but
I don't think you
it's up to them.
Yeah. No, I think
Those
just,
are definitely.
yeah.
I mean, no, he would have. I just don't think he was around
So-
as much in the summer. He probably.
So I'm trying to process that in my head. So, if there's a kid that is getting a C and you're like, they're not getting it, and you suggest they move down, you're gonna give the parents the option of.
No, it depends on why they're getting a C, I guess you could say. I mean, if it was a can't do, then I would probably suggest, I
Or
would say
just
they're,
tell them.
they're moving.
Okay.
If it's a won't do, then I would kind of counsel the parent.
Okay.
Okay,
Thanks.
I'll let you, hey, Isabel, how are you doing?
Okay, I went a little bit for you. I took DP2 this semester.
How'd that? Before Calc 3?
Yeah, I did. I skipped it, but then I'll take Calc 3 next semester.
Really?
Yeah,
Why?
but I was like,
DP2.
I was okay. I was doing okay, but I was like, I'm doing this bad, and I took like BC, and if I had, I don't know.
They let you take DP2 and beat with Calc 1? They
Well,
did?
no, I wasn't BC.
Oh, I know, but, I
Oh,
mean,
I don't think they would.
oh, okay, I was gonna say, then what do you mean you were doing this badly with BC?
Oh no, I wasn't doing bad with BC. I was just doing bad in like DP2. I was like, I felt prepared, but like I was still like,
Really?
what? Yeah. It was,
Wow.
but it's like new mathy stuff. Like there were some bits, like 3 fleeting moments where I did understand what I was doing, and I was like, oh, I love math.
And then
But
it was
most
a
of the time, I'm
disaster.
just so lost. But that's about it.
Wow. Yeah, I can't remember if I needed DP2. You don't need Calc 3 now for DP2? It looked like a Calc 3 planner, didn't it?
No, I can't count.
Yes.
Thank you.
Sure. So I did badly. So how about all your other classes and all the other stuff that goes in the house?
Everything is good. Yeah, I got so much fun about it.
Really?
It's probably like one of my best friends.
That's good. Was it just really rough first month? You guys you're super homesick or no big deal?
No, not really. I think he's like a year older than me because he took a gap year, so he's already pretty independent. Like he went and like worked on a farm in New Zealand for a year.
Cool.
I think I was ready to like I'm glad to be back. Though.
Yeah.
Yeah.
Yeah, I mean, my daughter is your age, and her first month, she was homesick, but she was enjoying it.
Yeah.
She didn't want to come home. After that, now she's just smooth and everything. Are you living out, you're going to mine, she said.
Yep, living on campus, yeah.
Okay, how's that?
It's good, I'm liking it.
Living with a Devlin kid or not?
No, I'm actually single, which I'm really enjoying.
Oh, yeah.
Just like
You are.
my own space,
I know, I would.
yeah.
That's good, but you still, I mean, you hang around with people
Yeah.
you met people, that's good. Cool. Well, guys, that's cool. That would have been the deciding factor for me. You have to get education. It's just that's good. And you're studying what?
Computer science.
That's like, so that's software, not hardware.
Right.
Computer engineering.
Yeah. Mine's has that too, but yeah. Engineering's more like physical.
Gotcha. And what are you going to study?
I think economics.
Oh, really? Oh, you have to have one. That draws on math big time. That's good. That's cool. That would be a cool one.
Yeah, because I really like them.
So you'll be rich someday. You'll probably be rich someday.
Probably. I'll take it.
Congratulations. I'm glad. That's cool. I'm glad it's going well. You got a good month or so before?
Yeah, right about a month for being a sophomore for this guy.
Really?
It's like another month.
Well, you already also have a very
Like 3 days.
I go back to 26.
Oh, isn't that the crap? I mean, high school, it's free, and they give you no break. College, you're paying for it, and they always come up. You get nothing for the month.
This is true. I mean, it's less stress than high school, but
Yeah,
yeah,
isn't
I'm
it
sure
way
that's not
better?
why I'm doing it.
Yeah, they give us a huge break, and then they're like, "Oh, we offer these programs, but they cost more money."
Yeah, oh yeah. I love college. Not the class, all taken time. It was way much time. It's just more time. I mean, I know you learn more, but you spend less time.
Yeah,
It
it's really nice.
I love it if you're motivated. People can't make themselves do the work usually. That's good. I'm glad you got it.
Got to know my problems.
You learned your lesson, obviously. That's good. So you took macro and micro, or just macro?
I took macro here, then I kind of just took like a bunch of different classes for a semester, and then I would take principles of economics. It's just more like bringing it all together.
Sounds actually put in mind score very well, which is good.
You have to take
Yeah.
econ.
Yeah, that'll probably be first semester next year for me.
You have to take an English class, or they don't do that at all?
You have to take like humanities crap, but not English. I've got nature and
I
human
think that would
values.
be a certain job in hell trying to teach humanities at mines. I could just imagine everybody from whatever, this is crap.
I mean, from what I've heard from people this semester, that's about what it is.
Really?
And people like fight for the professors that let you be on your phone the entire class.
Worst class ever taken to.
Yeah. Oh, so what I hear is it's also a lot of essay writing, so that's where the Devlin kids are really not having as much trouble.
Okay, thank you.
Yeah.
Yeah, I should hope so. They should put a coherent sentence together.
Imagine.
Yeah, I would like to think that any person in college could compose, but
I've done some peer review.
not so much. I don't even know what you're saying.
It's quite a calculation there.
Yeah, that was Newton's method kind of ugliness.
Yeah.
Did not go well. Yeah,
Is what that French.
pretty much. Let's go.
There's
Oops.
like 3 and then a lot of numbers, or 1 and 5 and then a lot of numbers, so that's it.
So you just got.
Yeah.
So you guys just got some break and you got a month to chill. That's good.
Taylor series.
Oh shoot.
This 6th degree Taylor series, Finding M.
Oh yeah.
Not my favorite thing to do.
It's good. It's fun.
It's fun when it's like 3rd derivative of an easy function, but when it's like 6th derivative of something stupid,
Yeah.
like give me a 2e to the x.
6 times over.
Do that, yeah.
Yeah, I guess I could see that. Let me know if you're here, Drew. Drew?
Shut up. Bye, Mr. Ekman.
Well, thanks for
Good to see you.
stopping by. Have a great second semester. Aparicio, are you here? I still don't know about research here. No. Is he tutoring? All right, Colin. Colin?
Yeah.
Cole?
Sure.
Sergio? Maddie? Tanya's tutoring. Kylie? Haley? Tim? Abby? Andrew? Allie? James? Ian? Martin? Did I stop this? Oh man, please tell me I stopped.